This chapter is about elasticity, which is one of the most useful and interesting concepts we study in this course. So elasticity tells you how much quantity purchased, if you are a seller of goods, how much quantity purchased will change if you change the price. So it helps you figure out which items you should put on sale and which you shouldn't bother to put on sale. If you put something on sale and lots more people come in to purchase it, then your total revenue may go up. If you put something on sale and it really doesn't affect the number of people that come in to purchase it, your total revenue is going to decline. So it's important to know which is going to happen when you think about which of your goods you're going to put on sale. So in this first problem, which is actually the second problem, the first one I skipped, I figured you could do that one. The second one is a step-by-step guide to calculating the price elasticity of demand. So the first piece of it, it gives us some information. The price of a laptop computer went from $2,700 to $2,980. During the same period, consumer sales decreased from 447,000 to 339,000 laptops. So price increase, quantity demanded goes down. The question is, by how much does it go down? Is it enough that total revenue goes up, or does total revenue go down? So the first half of this problem is just putting the numbers in. So the original quantity was 447. Find my pointer here. Okay, so the original quantity is 447,000. The new quantity is 339,000. Original price 2,700. New price 2,980. That's just writing in the information. So we use the midpoint method typically in this class to figure out elasticity of demand, because elasticity of demand changes as you move along the demand curve. So we took 447,000 plus 339,000 and then divided by 2 to get 393. That's where that came from. Then we took $2,700 plus 2,980 divided by 2, and we got 2,840 for the midpoint on the price. The change is just how much the quantity changed when the price went up. So 447,000, actually it's backwards, 339,000 minus 447,000 price. So the number of units sold went down by 108,000. The price went up, that's 2,980 minus 2,700 by $280. The percentage change then is the change, 108,000 divided by, so I could actually write this in here, 108,000 divided by the average, which is 393,000, and that equals a negative 27.48%. So sales went down by 27.48%. We figure out the percentage change in price exactly the same way. So 280 divided by 2,840 gets you 9.86%. So what that says is that we raised the price 9.86%, and we lowered the number of computers sold by 27.48%. We condense that then into one number, elastic or inelastic. So we take 27.48 divided by 9.86, and that gets us an elasticity of demand for laptops at 2.78. That's greater than 1. That's very elastic. So that says that if we raise the price of computers, the quantity sold will drop by quite a bit. If we lower the price of computers, the number purchased will rise by quite a bit. So that's what that tells you. It actually essentially tells you your total revenue, what will happen to total revenue when you raise price. Points A and B were when the price was 100 and the price was 80. What the total revenue is. So I started graphing, which is, so they gave you a graph of the demand curve. So you've got the price on one, price over here, quantity down here. So when the market price is $40 of whatever these things are, $40 right here, we sell 60 of them. So total revenue is 40 times 60, which is 2,400. So when the price is 40, total revenue is 2,400. When the price is 100, again, I read that up here. Price was 100. Total revenue was, quantity sold was 42. So total revenue is 4,200. So that's this one right here. And you graph all those prices just exactly like that so you can see what's happening to total revenue. So total revenue goes up, flattens out, and if I had done the rest of this graph as it goes up to 140 and 160, it actually begins to decline. So eventually as you raise prices, total revenue declines because fewer and fewer people are interested in purchasing at the higher price. So you can figure out the elasticity demand between those points. I have to admit, when I did this problem, I didn't actually do the math to figure out what that was. You can do the math to figure out the 0.6, but the question gives you alternatives. The alternatives were an inelastic point and an elastic point. I could tell it's inelastic. So how do I know that it's inelastic? I know that it's inelastic because as we raised the price from $80 to $100, the price went up by more than the quantity went down in percentage terms because total revenue was still going up. So from 80 to 100, total revenue went up. So the reaction to a cut in price must have been a lot. The reaction to a raise in price must have been fairly small. Or try again. The reaction to an increase in price was fairly small because total revenue went up. So suppose the price of Bitty Bops is $100 per Bitty Bop as shown on price A. Because the price of elastic demand between points A and B is inelastic, again it's less than 1, a $20 per Bitty Bop decrease in price will lead to a decrease in total revenue per day. So you drop your price, not that many people pay attention to it. They're not really interested in the price of this good. Really, they just want this good. So in general, then they ask the reverse question here, which makes me a little crazy. In order for a price increase to cause an increase in total revenue, demand must be inelastic. So demand has to be inelastic for us to go from an $80 price to a $100 price and have total revenue increase. Because again, we needed demand that people weren't really interested in the price. They just wanted the good. Okay, did one more question, question 5. This was long run, short run supply. So it gave us the gray line here is long run supply. So in the long run, supply tends to be more elastic. In the short run, supply tends to be inelastic. Why is that? That's because in the long run, we can do more things. In the long run, we can hire more employees, we can fire more employees, we can build new plants, we have new ways to process things. So in the long run, your reaction as a producer to a change in price can be fairly large. In the short run, however, lots of those things are fixed. So in the short run, you're probably stuck with the plant you've got. You may be stuck with the equipment that you've got. You may be stuck with the employees that you've got. You can't expand in the short run. And ditto with shrinking. You can't shrink in the short run. You've got contracts out there. So in the short run, supply tends to be more inelastic. In the long run, it tends to be more elastic. So when the question asks for a short run supply curve, I made it steeper because that's what that says. So in the short run, if we change the price from 16 to 24, or 16 to 32, on this curve you have a fairly large reaction, or small reaction, I'm sorry. And on this curve you have a much larger reaction in terms of 20. So here at 16 we're producing 2, at 32 we're producing 6. So we had a 4,000 increase. That's long run. In the short run we want a smaller increase. So we go from here, which is about 3, again to about 6. So more inelastic in the short run. And that is it for this chapter. Cool concepts though, so spend some time on them.